Hi, Mr. Corsi here. This question involves a formula which tells us the percentage of customers who wait for less than T minutes. This is done over the course of half an hour, the number of customers that wait less than T minutes in a certain supermarket. So let's just have a look at this formula and see the various parts of it. There's the number E raised to the power k times t. And the explanation says this is the percentage of customers, and t is the time waited, waiting time. And in this part A, we're told 50% of customers wait for less than 3 minutes. In other words, P is 50 and T is 3. And we're asked to find the value of K. So let's just substitute these values in. 50 is 100 times 1 minus e to the power 3k. K times 3, 3k. So let's try and solve this equation. Let's divide both sides by 100. 50 over 100 is a half, that's 0.5. And 1 minus e to the power 3k, so that gets rid of the 100. Let's add e to the power 3k to both sides. And let's take away 0.5 from both sides. So 1 minus 0.5 is 0.5. Now, here we have a power statement, similar to something like 10 squared equals 100. All power statements can be written as log statements. In the case of 10 squared equals 100, log to the base 10 of 100 is equal to 2. So this index here, 3k, is equal to the log to the base 10 of 100, log to the base e of 0.5. That's the pattern that is probably easier to remember. A familiar example and then translate it into this. I suppose the other way of doing it is to take the log to the base e of both sides and then use your laws of logs. That 3k comes down to the front, and what power do you raise e to get e? Well, the answer is 1 to that bit. So we get 3k times 1 is equal log to the base e of 0.5. So either way, that log statement comes out of it. So to find k, which is what we're after, we have to find 1/3 of log to the base e of 0.5. So we need to call in the help of our calculator. Now on the calculator there are two log keys. The log is log to the base 10, ln is log to the base e, or the natural log as it's sometimes called. So we have to take the log to the base e of 0.5 and divide it by 3. So the log of 0.5, whatever that comes to, and take 1/3 of it, so divide it by 3. And there's our answer, negative 0.231. And I'm going to round it off to 3 significant figures. Remember, the 0 at the front's not significant. So it's approximately negative 0.231, and that's to 3 significant figures. So there's part A successfully conquered. Let's go on and have a look at part B. This asks us to actually use the formula now to calculate the percentage of customers who wait for 5 minutes or longer. Now notice that T is not T minutes or longer, it's less than T minutes. So first of all, let's work out what percentage of the customers wait for less than 5 minutes, and then presumably we say that the rest of the customers waited for 5 minutes or longer. So watch the phrasing in this question. So what is the formula we're using to find this percentage? It's 100 minus 1 minus e to the power. Well, we worked out what k was. It's negative 0.231 times t now. And when t equals 5, now remember this works out the percentage of customers that waited less than 5 minutes. So when t equals 5, p is equal to 100 times 1 minus e to the power negative 0.231 times 5. And there's a calculation again we need to do on the calculator. So let's first of all, there's the e to the power x button. Let's work that out. E raised to the power, it's negative 0.231 times 5. So that's what I'm raising e, the power I'm raising e to, which gives me that number. I have to take 1 minus that number, 1 minus that number there. That gives me this, and then I have to multiply that by 100. So there is the percentage I'm after, 68.494. But that's the percentage of customers who waited 5 minutes or less. So the percentage of customers waiting, sorry, did I say 5 minutes or less? Less than 5 minutes. That's the percentage of customers. So those waiting 5 minutes or more would be 100, that's all of them, 100% minus this percentage. So waiting 5 minutes or more is 100 minus 68.494, etc. So into this calculator then, let's do 100 minus that number there, giving me 31.50. So it's 31.505 and so on. So the required percentage is 31.5, and again that's to 3 significant figures. 31.5%. So that's Mr. Corsi signing out, and thanks for watching this video.